All right, example 2. Here's a point acted on by a push force and a pull force as shown. Find the resultant force on the point. So what we have here is a push vector here, magnitude 10 acting on that point. So what I'm telling you about a push vector is this. It's real simple. Polling the same point in the same direction is the same thing, okay? So we're going to keep a 10 magnitude. Again, it could be newtons, pounds, whatever. But if I pull with a force of 10 this way, or I push with a force of 10 that way, it's the same force. But pull vectors are better to work with. So that's what we have.
That 10 isn't needed anymore? That 10 doesn't
Well, yeah, this 10 is that 10, right?
Okay.
Whatever this is that. So instead of using this vector here, we're using that one there. We want every vector to be a pull vector. So if the problem in my book looks like this, I would draw this on my paper. Right? And I got a green vector. Let's make the other vector red. Before I do this problem, imagine this happening. All right, there's our two vectors. Somebody's pulling this way with a force of 16. Somebody's pulling this way with a force of 10. Where do you think the resultant vector should be?
Well, in the middle.
In the middle of them, right? And in addition, not only in the middle, but probably longer than both, right? Somewhere like that. Because both people are working in kind of the same direction. This guy's just causing it to go up, right? So horizontally, they're both pulling this way. Vertically, one's going flat, the other's going straight up. So all the force is going pretty much in the same direction. So it's going to be more force than either one individually. But it's going to go up a little bit because that one's pulling up some. That's what's happening here. That's what resultant force is. Where's the end result go? So, looking at my two vectors, let's start with the green one. All right? Its magnitude is 10. What is its angle? What is it?
30. It's straight across.
Is it slanted?
No.
It's slanted. It's not slanted, so it's either 0, 90, 180, 270. Those are the four choices. If it doesn't slant, it's going to be 0, 90, 180, 270. I can't get my... I'm going to break my arm trying to explain this problem. All right. Doesn't slant, so it's going to be one of those four. So straight right is 0 degrees. Be very careful. Again, there's an angle measure sitting right there, and you need an angle measure, so it's very tempting. I'm going to put a 30 right there. I'm going to put a 30 on everything. I see a 30, that's the only angle measure. Must be the right angle measure. No. Non-slanted is either 0, 90, 180, 270. Those are the four choices. The slanted vector is in the first quadrant, because again, we want to superimpose a coordinate system on this. So if I drew a y-axis and an x-axis, first, second, third, fourth quadrant, the red vector is very clear in the first quadrant. So that means that this equals alpha, but in the first quadrant, theta equals alpha, right? So the angle they gave me is the angle I'm going to use. So again, priority one on these problems, make sure both vectors are written with the correct angle. You write the correct vector addition problem, your chances of getting the problem are still there. Okay? If you write the wrong problem here, you're not going to get the right answer. Okay? I've never seen a student ever write the wrong problem and get the right answer, ever. Not even once. All right? Even the ones that copy out of the back of the book, they still somehow manage to get the wrong answer on when they write the wrong problem. So don't be that person. Now, I could type in 10 cosine 0, 10 sine 0 on my calculator, right? I could also just write 10I plus 0j. How in the world did I do that?
Because you're not adding.
What do I and j represent?
How
How far you go horizontally and how far you go vertically, right? I'm going 10 horizontally, 0 vertically, right? 10 to the right, 0 up or down. If I type it in though, watch 10 cosine 0 equals 10 sine 0 equals. It's like magic. Crazy. All right? Again, a non-slanted vector only has one number, okay? And that one's going to be 0. All right. For the 1630, if I do 16 cosine 30 and 16 sine 30, I get 13.86 I plus 8j. So therefore my resultant vector is simply going to be the sum of the horizontal and vertical components. Everything is either positive or 0, so it just adds everything. So 23.86i plus 8j is my resultant in rectangular form. What's left to do then again is convert back to polar form. Step 1, notice everything's positive, so it makes life even easier than normal. R equals the square root of 23.86 squared plus 8 squared. And that equals 23.86 squared plus 8 squared in parentheses. Notice square root parentheses, the entire sum in parentheses, 25.16, 17 even, 25.17. Notice 25.17 is more than either one of those together, right? 116, 110. So almost, in fact, if I just added them up, 26, almost all the force is going in the direction we're supposed to be going. Number 2, alpha is going to be inverse tangent of what over what?
8 over 23.86.
8 over 23.86. Always the second over the first number. Absolute value, which again, it's all positive anyway, but always positive. Inverse tangent, 8 divided by 23.86 comes out to 18.54 degrees. And step 3, we can see very clearly that we're going to the right and up. Oops, that's not right. So we're going right 23.86, going up 8. All right, that puts me in what quadrant? First quadrant. The first quadrant, theta is equal to alpha. So we can see very clearly the magnitude 25.17, angle 18.54. There's my resultant force. Draw the picture on your paper, label all the alphas correctly, but again, be aware they are alphas, not thetas. If you have a non-slanted line, know it's either going to be 0, 90, 180, or 270. Don't be looking at the angle measure written on your paper and think, oh, I got to use it right away. All right, slanted one has an angle measure that you care about. Straight one, non-slanted, one of the 4 possibilities. All right, and that's how you do those. There's no shortcut to it. That's it. So make sure that you go through the process each time.